Good morning everyone. Welcome back. I'll continue trigonometrical identities. In previous video I had done some proving. I'll be doing some more difficult sums. So please do watch the video till the end and practice the same sum which I am doing in the video itself. The more you practice, the more you will understand. Question number 13 from the exercise. Question says that prove 1 plus sine A divides by cos A plus sine cos A divides by 1 plus sine A equal to 2 sec A. This is an important question. Look at this one. Take left hand side. You have fraction either side. In between you have plus sign. So when you simplify these kind of sums where you see fractions, take LCM. And when you take LCM, you just need to copy these two denominators inside bracket. Cos A 1 plus sine A. When we take LCM of trigonometrical terms or algebraic term, numerator of first multiplies with denominator of second. 1 plus sine A multiplies 1 plus sine A plus sine, denominator of first multiplies with numerator of second. Cos multiplies cos is cos square A. Proceed with algebraic multiplication here. 1 multiplies 1, you get 1 plus 1 multiplies sine, gives you sine A. Similarly, sine multiplies 1 is sine A, plus sine multiplies sine is sine square A, plus sine cos square A. Write denominator as you had, you should not multiply it. Multiplication is done only when you have algebraic terms like 1 plus sine A, 1 minus sine A, then you proceed with multiplication. Otherwise, you just leave it like that. 1 you write as it is, these two are like terms added up, 2 sine A. Use identity for this. Sine square A plus cos square A is 1. Divides by cos A bracket 1 plus sine A. Add the numerator. 1 plus 1 gives you 2 plus 2 sine A. Copy denominator cos A. 1 plus sine A. You have 2 common at numerator. Take it out. As you take 2 common, 1 is left for this plus sine A. Divides by cos A. And then you get 1 plus sine A. 1 plus sine A from numerator, 1 plus sine A cancels. You are left with 2 divides by cos A. Use reciprocal relation. 2 divides by 1 upon sec, because cos can be written as sec. Reciprocate, you get 2 sec A. Left hand side is equal to right hand side proved. This is how we prove when we have fractions. Question number 14 is similar sum. You can try question number 14, but I am doing it. Have a look. Sec A. I'll change the sum. Sec A minus 1 plus sec A divides by sec A plus 1 equal to 2 cosec square A. I'm doing with different trigonometrical ratio. You can try that question from the exercise. Left hand side. Similar question, you can change this one into 1 upon cos and proceed, or you take LCM. If you proceed with LCM, the calculation will be easier. Left hand side, copy these two denominators inside bracket, sec a minus 1, sec a plus 1. Numerator of first multiplies with denominator of second, sec a multiplies sec a plus 1 plus sign, sec a multiplies denominator of first. Simple algebraic simplification. Now we open the bracket and multiply this. We get sec square a plus sec a plus sign. Again we multiply this. We get sec square a minus sec a. At denominator you have two like terms, sec a minus 1, sec a plus 1. One is minus, another one is plus, so we use algebraic formula to simplify this. A plus b, a minus b can be written as a squared minus b squared. So similarly we write this one as sec square a minus 1 minus sec a plus sec a cancels from numerator. You have two like terms added up to sec square a. Then you have to use identity here. Sec square a minus 1 is written as tan square a. Since on the right hand side you have to prove cosec, so start changing it to into sec square can be written as 1 upon cos square a. Tan square can be written as sin square a divides by cos square a. Now reciprocate this. 2 into 1 divides by cos square a. Multiplication, you get cos square a divides by sin square a. Cos square a cancels. And you are left with 2 into 1 by sin square a. You have to prove it as cosec, so reciprocate. Sin can be written as 1 upon cosec square a. Change it 2 into cosec square a. Left hand side is equal to right hand side. Prove. Same application, taking LCM, then you have to use trigonometrical identity as some places. So you have to practice this. There are certain chapters we need lots of practice, and then you'll slowly know the steps. You'll start realizing at this particular step you have to use this formula, have to do algebraic expansion, have to do multiplication. Because each and every sum is different from one another. Look at this question number 16. Question says that cosec to the power of 4 theta minus cosec square theta is equal to cot to the power of 4 theta plus cot square theta. Either you can take left hand side or right hand side. You prove. I am taking left hand side. Have a look. You have cosec to the power of 4 cosec square. So we take common from this. We get cosec square theta outside. You are left with cosec square theta minus 1. Again, this cosec square theta can be written as identity. Cosec square theta can be written as 1 plus cot square theta into this cosec square minus 1. Cosec square theta minus 1 can be written as cot square theta. Open the bracket and multiply it. 1 multiplies cot square theta plus cot square theta cos square theta is cot 4 theta. left hand side equals to right hand side, proved. You can try this question similar. I'm changing the value. Tan theta, tan to the power of 4 theta, tan square theta. Sec to the power of 4 theta minus 6 square theta equals to tan to the power of 4 theta plus tan square theta. Try this in similar steps. But trigonometrical identities formulae will be different. Question number 17 is an important sum. It is 1 plus cos theta minus sin square theta divides by sin theta bracket 1 plus cos theta. Look at this question. If you want to simplify this, then this term, keep it inside bracket. 1 plus cos theta minus, use identity and write this one as 1 minus cos square theta. Whole thing divides by sin theta 1 plus cos theta. You cannot cancel it because there is minus sign. There are two terms. 1 plus cos theta you copy. Use algebraic formula to expand this. 1 plus cos theta 1 minus cos theta. Copy denominator as you have. Sin theta bracket 1 plus cos theta. Still you cannot cancel because there is minus sign. So you take common. These two terms is taken common. 1 plus cos theta is taken out. Put curl bracket. You have 1 left here. Minus. These term is left. 1 minus cos theta. Close the bracket. Divides by sin theta bracket 1 plus cos theta. Now you can cancel. Numerator cancels with denominator. Cancellation is allowed only for multiplication. Now you are left with 1 minus, open the bracket with minus sign, plus cos theta, whole thing divides by sin theta, minus plus cancels, you are left with cos theta divides by sin theta, which is equal to cot theta. Left hand side is equal to right hand side, proved. Look at the question here. I'll give you one more sum similar to this for practice. Try this one. 1 plus sin theta minus cos square theta divides by cos theta bracket 1 plus sin theta is equal to tan theta. Similar question, same steps, identity, then simplification will be similar. Look at this question number 18 part 2. Root, it is 1 minus cos A divides by 1 plus cos A. You have to prove it as sin A divides by 1 plus cos A. Look at this question, it had come in ICSE 2013. Left hand side. You need to look at the right hand side. On the right hand side, plus sign has been retained as it is, plus, so you have 1 plus cos A. And since the sign is retained, so you have to simplify this by rationalization. Put multiplication sign. Same sign has been retained, so you have to rationalize minus 1 plus cos A divides by 1 plus cos A. Right hand side tells you which term, numerator or denominator, to rationalize. It was plus sign on the right hand side, so we rationalize minus. We use algebraic formula at numerator. Okay, I'll write this 1 minus cos A multiplies 1 plus cos A. You have like terms at denominator, so we can directly write it as 1 plus cos A whole square. Like we have A plus B multiplies A plus B. Directly we can write it as A plus B whole square. So similarly, when you multiply like terms, you put whole square. Root minus plus algebraic formula. A minus B multiplies A plus B, which is written as A square minus B square. So 1 square is 1 minus cos square A. Whole thing divides by 1 plus cos A whole square. Now you simplify it. Use identity here. 1 minus cos square can be written as sin square A. Denominator you have 1 plus cos A whole square. Numerator square, denominator square, you put inside bracket and square the whole. You have sin A divides by 1 plus cos A. Square and root cancels. You get sin A divides by 1 plus cos A. Left hand side is equal to right hand side proved. You can do same question using another value. I'll give you this, have a look, and please do it yourself. Root 1 plus sin A, 1 minus sin A divides by 1 plus sin A is equal to cos A divides by 1 plus sin A. This is another homework. Look at the second sum now. And it is another important question based on similar property. Root 1 plus sin A divides by 1 minus sin A equal to, it is tan A plus sec A, tan A plus sec A. Copy the left hand side. Similar steps are involved. Root 1 plus sin A divides by 1 minus sin A. Put multiplication side. Look at the right hand side. You have plus sign. So this plus sign has been retained. So you need to rationalize minus 1 plus sin A, 1 plus sin A. Rationalization. Like terms at numerator multiplies, so you can directly write 1 plus sin A whole square. Algebraic formula at denominator 1 minus sin square A. Because minus and plus gives you minus A plus B, A minus B is A squared minus B squared. Root, keep numerator as it is because you do not have formula like this, 1 plus sin A whole square. 1 minus sin square is based on identity, so it is written as cos square A. Numerator has square, denominator has square. Keep these two terms inside bracket and square it. 1 plus sin A divides by cos A. Square and root cancels. You get 1 plus sin A divides by cos A. Left hand side and right hand side you have 1 plus tan A plus sec A. Divide individually. 1 divides by cos E. Sine divides by cos E. So what do we get? We get 1 by cos E sec E. Sine divides by cos E tan E. Left hand side is equal to right hand side proved. Left hand side equals to right hand side proved. Application of trigonometrical identities, application of algebraic formula, and then simplification. Trigonometry is combination of all, so you need to practice it regularly, and once you know the sum you can easily solve it. Thank you very much. Stay safe.